Kita lihat lagi pengaruh runway pada prestasi pesawat. Ya. Tadi runway itu atau landasan itu bisa bermacam-macam bentuknya. Ada yang seperti sini ya, yang pakai aspal, ada yang pakai beton, ada yang rumput, ada yang tanah, ada yang ini tertutupi oleh es, tertutupi oleh snow, itu macam-macam ya kondisi runway. Ya, kita lihat bagaimana seorang pilot untuk bisa menghitung atau memprediksi keadaan kondisi runway.
To get an idea of runway surface conditions, one might use the taste test method. But as it turns out, there's a better way. As GA pilots, we should be familiar with the FAA language used to describe runway landing surface grip, especially if we're planning to venture out into the winter weather. You may have heard words like TALPA, RCAM, or FICON. Well, that's a lot of acronyms, so we'll break things down a bit. On December 8, 2005, at Chicago Midway Airport, a Boeing 737 ran off the end of a runway and into a city street after landing in a snowstorm. The airplane collided with automobile traffic, killing one person and injuring several others. So this accident became a catalyst for the FAA to develop new standards to improve runway safety during bad weather. In October of 2016, the culmination of the FAA's efforts led to what's known as TALPA, the Takeoff and Landing Performance Assessment.
Ya, ini adalah TALPA. Anda akan sering mendengar ini. Adalah kinerja pesawat pada saat di landasan ya. Take off and landing performance assessment. Bagaimana menganalisa prestasi terbang pada saat take off dan landing. Ya, pada saat weather atau cuaca yang berbeda-beda. Ini terjadi karena ada beberapa kecelakaan seperti tadi kita lihat ya. Pesawat yang sampai ujung masih belum berhenti akhirnya melukai jiwa seseorang.
This initiative aims to improve the quality of runway condition information and thereby reduce the risk of runway overrun accidents and incidents. TALPA provides a standardized format that gives a pilot useful information to anticipate airplane braking performance. As part of TALPA, airport operators are using the Runway Condition Assessment Matrix, or RCAM. And what the RCAM does is replace subjective judgments of runway conditions with objective assessments tied directly to contaminant type and depth categories. Here's how it works. An airport operator will assess the surfaces of each runway in 3 equal parts and provide a measure.
Nah, ini bagaimana cara menganalisa kinerja pesawat terutama tentang landasan. Karena landasan tadi kan cuacanya berbeda, akan berbeda. Nanti landasan ini dibagi 3, tiap bagian ini dihitung angkanya berapa. Ya, angkanya berapa, RCAM-nya berapa, RCAM. Ada bisa 6, bisa 5, bisa 3, bisa 2, bisa 1, bisa 0. Ini ada hitungan-hitungannya ya. Kalau kering, dry, bagus, angkanya tinggi 6. Kalau dia jelek, basah, licin, bisa 0. Nanti dijumlah, nanti bisa dihitung, oh kondisinya angkanya berapa. Jadi tidak subjektif lagi, tapi berdasarkan angka.
Description of each third. Based on the contamination they find, shown here in the left column, they will then use the RCAM to determine the numerical runway condition codes. Now these codes may vary for each third of the runway if different contaminants are present, or if conditions are uniform throughout, the numbers will be the same. Let's say, for example, the airport operator observes that 70% of the first third of the runway is covered with 1/4 of an inch of wet snow. 60% of the second third of the runway is covered with 1/4 inch of wet snow, and 90% of the last third is covered with 1/8 inch of slush. Based on the
Ya, jadi di sini sebagai contoh ada pesawat sedang mendarat, ternyata landasannya beda-beda ya. Di yang bagian ini dia terisi jadi banyak wet snow-nya. Ya, banyak slush-nya. Di yang ini 60%-nya juga banyak slush-nya. Tapi di ujungnya ini dry snow, ya, snow-nya berbeda. Ya. 3 mm depth atau less. Jadi yang ini angkanya 5, yang ini angkanya 3, yang ini angkanya 3.
RCAM The corresponding runway condition codes would be 3, 3, and 5. You can find this information in the form of a NOTAM or from an ATC facility, flight service station, or airport operator via the CTAF. Now let's take a quick look at the way our example would appear in a runway field condition notice to airmen, or FICON NOTAM. Here's our runway condition codes.
Ya, pada FICON, ini ada istilah lagi, FICON. Ada pemberitahuan lah, ya, pemberitahuan dari yang punya landasan bahwa sekarang kondisinya 335, ya, seperti tadi dihitung. Jadi dibagi 3 tuh landasan dibagi 3, jadi yang pertama nilainya 3, yang ini 3, yang ini 5, ya. Ini kondisi yang diberikan kepada pilot. Ya, harus mengerti 335 itu ya kondisi landasannya seperti itu.
As well as our percentages. If less than 25% of a runway is contaminated, runway condition codes won't be generated. Also included in the RCAM is the quality of braking action that pilots can expect for a given runway condition code, ranging from good all the way down to nil, although if it's nil, the airport is required to be closed. When available, ATC will provide the quality of braking action received by pilots or airport management. Hopefully, this helps to demystify the reporting language that comes with the winter weather. And remember, it's still important to file pilot reports on braking action, so review those descriptions in the RCAM and keep filing PIREPs.